Decks are subject to wind and seismic loads that can cause decks to move. Movement can weaken the connections it supports and contribute to deck collapse. Bracing helps decks resist the movement. Bracing parallel to the deck support beam is required on all decks that are more than 2 feet above the ground. This height will vary by jurisdiction. Bracing is also required perpendicular to the deck support beam when the deck is not attached to the house, a freestanding deck. Looking at this diagram here, we see that deck bracing parallel to the beam. We see that the bracing is attached to the beam, and that bracing is required only if the deck is more than 2 feet above grade. We have 3/8 inch diameter bolts with washer on both ends. When pressure-treated lumber is cut, the cut end is no longer pressure-treated. These ends are subject to rot and to insect damage. Cut ends of pressure-treated lumber should be field-treated with copper, naphthenate, or other approved wood preservative, and this is rarely done. Deck columns, footings, and beams. The recommended wood deck support post is a 6x6 made from pressure-treated or naturally durable wood with a maximum height of 14 feet. This maximum height will vary by jurisdiction. Wood deck support posts using 4x4s are common with a maximum height of 8 feet. Steel deck support posts should be at least Schedule 40 thickness, at least 3 inches in diameter, and painted with rust-resistant paint inside and outside. The maximum height of steel deck support post should be determined by the engineering analysis. The unsupported span of a deck beam depends on the deck floor joist length and on the size and quantity of the members that make up the beam. Deck beams are usually 2 or 3 members thick and are usually made using multiple pieces of wood. This means that a beam may have a joint at some point where the 2 members meet. Joints should occur over a support. Home inspectors should look carefully at the beams consisting of 3 members to be sure that the joints and the same center member occur at a support. In this diagram, we see the deck beam specifications. For 3-member beams, attach both outer members to the inner member as indicated. We see here that there's 2 nails or wood screws at each beam. And we have 10D nails at 16 inches on center, staggered in 2 rows. And the beam span per AF and PA table or other approved method. And we see here that we have a beam splice only at the support, and that there's optional cantilever maximum distance equals 1 joist space or 16 inches. Deck beams should fully bear on top of deck support post. Attachment of beams to the sides of post is not considered acceptable in many areas. Deck beams should be attached to the top of post using machine bolts or by using a manufactured post cap. Beam attachment to post using straps is allowed in some jurisdictions, and nails are allowed in some jurisdictions on decks near the ground. Note that all members of a 3-member beam will not be supported on top of a 4x4 post. Looking at this diagram, we see deck beam support. Alternate support method required if greater than 3-member beam. Manufactured post cap such as Simpson BCS. We see that there are 6x6 posts less than 14 feet and 4x4 posts less than 8 feet. And that is notched 6x6 post support method with 1/2 inch bolts with washers. The size and thickness of deck footings is based on the size of the deck and the spacing of support posts. The bottom of deck footings should be below the local frost line if the deck is attached to the house. This is not required for freestanding decks, although it is a good practice. The bottom of deck footings that are closer than 5 feet to the foundation should be the same level as the house footings to avoid placing a load on the house foundation walls. Deck support posts should be secured to the footing. Wood support posts should be secured using a post base. Embedding wood posts in concrete is considered acceptable in many, but not all areas. This method increases the chance that the post will degrade over time because of constant exposure to moisture. Looking at this diagram, we see deck footing specifications. Footing thickness and surface area depend on deck size and soil conditions. We see that the typical depth is less than 12 inches below finished grade or below the frost depth, and that the typical bearing surface area is 128 576 square inches, and the deck footing is less than 5 feet from the house foundation, must bear on the same level as the house foundation. The typical thickness is 6 to 10 inches. Defects, maintenance, safety standards. Typical defects. Flashing and sealants. 1. Deck ledger and deck door threshold flashing are absent and properly integrated with other flashing and with wall drainage plane. 2. Gaps exist in flashing. 3. Improper flashing material is used. 4. Sealants are absent or deteriorated where joists and guards penetrate the wall coverings. 5. Excessive sealant has been applied, evidence of previous or current water infiltration problems. 6. Evidence of water infiltration exists at locations including the band, rim joist, in, around, and under the deck door, and where components, such as guards, penetrate wall coverings. Home inspectors may wish to move insulation or lift carpet to detect water infiltration. 7. Step between deck and door is too small. Typical defects, deck ledger attachment. 1. Ledger is attached using only nails. 2. Quantity or size of bolts or screws is inadequate. 3. Nuts are not fully engaged on bolts or screws, are not fully penetrating. 2. Quantity or size of bolts or screws is inadequate. 3. Nuts are not fully engaged on bolts or screws, are not fully penetrating the band rim joist. 4. No washers are on bolts or screws. 5. Bolts or screws are not staggered vertically or are too close to ledger or band and rim joist edges. 6. Band rim joist or ledger is absent, deteriorated, or improper type or size. 7. Ledger is attached through wall coverings. 8. Ledger is attached to cantilevered structure such as a bay window or framed fireplace chase. 9. Woods used is not approved for outdoors. Typical defects, deck stairs and landings. 1. Stringers are inadequately attached to the deck. 2. Stringers are pulling away from the deck. 3. Stairs deflect when used, often caused by defects 4, 5, or 11. 4. Cut stringers have less than 5 inches of undisturbed wood. 5. Stringers unsupported, horizontal distance is too long. 6. Distance between riser heights or tread depths is too large. 7. Space between open risers is more than 4 inches. 8. No solid landing exists at the bottom of stairway. 9. Landing is too small. 10. Tread unsupported horizontal distance is too long. 11. Stringers or treads are deteriorated. Typical defects, handrails and guards. 1. Handrail or guards are absent or not continuous over all of the stairway. 2. Handrail or guards are loose. 3. Handrail size or shape is improper. 4. Handrail or guards are an improper height. 5. Guard posts are notched. 6. Guard posts are attached with nails or screws or with inadequate size or type of bolts. 7. Guard posts are spaced too far apart. 8. Balusters are spaced too far apart. 9. Handrails, balusters, or guard posts are deteriorated. Typical defects, framing. 1. Deck slopes toward the house or inadequately slopes away from the house. 2. Deck joists are secured to the ledger or beam using only nails. 3. Joist hangers or angle brackets are improper size, are not galvanized or stainless steel, and all holes are not filled with fasteners. Incorrect fasteners are used. 4. Improper quantity or size of nails are installed under floor joist supported by a ledger. 5. Floor joist or flooring unsupported horizontal distance is too long. 6. Fasteners are driven too far into the flooring. 7. Deck bracing is absent, improperly installed, improperly secured. 8. Joist or flooring are deteriorated. 9. Cuts in pressure-treated lumber are not field-treated with copper, naphthenate, or other approved wood preservative. 10. Wood used is not approved for the outdoors. Typical defects, columns, footings, and beams. 1. Column is too tall for the size and type of material. 2. Column is leaning or deformed. 3. Column is not properly attached to the footing. 4. Beam is not properly attached to the column. 5. Wood column is split. 6. Footing area is too small of footing depth, inadequate. 7. Column or beam is deteriorated, especially at the column bottom. 8. Beam is attached to the side of the column. 9. Beam is leaning or deformed. 10. Beam splice does not bear on the column. Maintenance safety issues. 1. Wood decks usually last longer when pressure washed and sealed on a regular basis. 2. deformed and damaged deck flooring and fasteners, protruding fasteners can be a trip hazard. Standards: 1. IRC 2012 R507. 2. Prescriptive Residential Wood Deck Construction Guide DCA 6-12. American Wood Council. 3. Manufacturer's Instructions for Composite Deck Flooring and Railing. Okay, on site conditions, we've come to some review questions. 1. A poured concrete retaining wall with weep holes is rotating. What is the most likely reason for the rotation? C. There is no gravel behind the wall. 2. A poured concrete basement wall has a 1/4 of an inch wide crack where the wall is bowing slightly. Brown stains are below the crack. What is the most likely reason for this condition? A. The gutters are blocked. Number 3. A concrete block basement wall has significant efflorescence. What is the most likely reason for this condition? D. The soil has settled at the foundation. 4. A concrete driveway is a 1/2 inch higher than the adjacent concrete walkway. What is the most likely reason for this condition? B. The soil under the walkway was not compacted. And 5. Which is the most acceptable fastener for connecting a deck ledger to a band board? And we see here the answers to the review questions for site conditions. 1 is C, 2 is A, 3 is D,